this will be the Cannon Lab demonstration. So in the Cannon Lab we had a knot potato gun right here, and initially it had a nice little racquetball inside it right there. Okay, after the explosion, right, we're calling it an explosion not because it exploded but because the things separated. So an explosion is when things are separated. At the end, the racquetball was traveling with some velocity that was unknown, and the cannon was recoiling backwards with some velocity that we calculated. Alright, so let's just do an example. Let's just use some made-up numbers to solve for this. Alright, so let's say that the mass of the cannon is equal to 4 kilograms. It's not what it was in the lab, but just giving an example. The mass of the racquetball, let's say, is 0.05 kilograms because it's a rather small object. The velocity of the cannon that we calculate using the photo gates, let's say, is 2.5 meters per second. We want to know the velocity of the racquetball after it comes out. Alright, so this is what we're looking for. The velocity of the racquetball after it comes out. So we need to remember the momentum initially equals momentum finally. We need to remember that the momentum is calculated by adding up the momentum of both objects in the system. So before, we have the momentum of the cannon plus the momentum of the racquetball. They're together because in the problem, right, the racquetball is attached to the cannon. Their initial velocity is 0 because they are not moving. Alright, so their initial velocity is 0, and that's equal to the momentum of the momentum finally, which is equal to the the mass of the cannon times the velocity of the cannon plus the mass of the racquetball times the velocity of the racquetball. Now, you should note that the initial velocity was 0 because it's not moving initially. And so 0 should equal the mass of the cannon times the velocity of the cannon plus the mass of the racquetball times the velocity of the racquetball. Alright, and that should quickly lead you to this conclusion. The mass of the cannon, velocity of the cannon should equal the mass of the racquetball times the velocity of the racquetball, except negative. Alright? So the velocity of the cannon, since the cannon is recoiling backwards, would be negative. So the mass of the cannon was 4 times 2.5 negative equals the mass of the racquetball equals the mass of the racquetball, which is 0.05 times the velocity of the racquetball. And we're solving for the velocity of the racquetball. So 4 times negative 0.25 is negative 10 times the negative gives us just 10 equals 0.05 velocity of the racquetball. And 10 divided by 0.05 is 200 meters per second, and that would be the velocity of the racquetball. Okay, so I hope this helped you out. If it did, great. If not, then you may need to come see me.